Welcome back. So in this last video, I went through this example and I kind of laid the groundwork for the fact that there's a pattern here, and that whenever there's a pattern in mathematics, we can develop an algorithm. And I kind of want to talk to you about why this turns out to be an important thing. What we're really doing here is we are combining waves of equal period. And this has a lot of application in sound engineering, in audio engineering, because the period of a sound wave is directly related to the pitch. So if you want to amplify a sound without losing its tonal quality, this is really what you're doing. And so this comes into play in AM and FM radio transmissions and in speaker design and in all sorts of other places. And so this really does have an application. It's primarily in the audio and electronics industries. But what we're doing is, if we want to rewrite, Okay. So what we're going to do is we're going to rewrite m times the sine of bx plus n times the cosine of bx. And we're going to rewrite that in the form of a times the sine of bx plus c. So in the example we just did, a would be 4, b would be 3, and pi over 3 would be c. Now, we actually went backwards in that last example. And so m turned out to be 2, n turned out to be 2 square root 3. Now I want to remind you where that m came from. That m came from 4, which is a, times the cosine of the second angle, the c. And that n came from 4, which is a, times the sine of the second angle, which is c. And that is our algorithm here. So what we know is that a squared is always going to be equal to m squared plus n squared, and that m over a is always going to be equal to cosine of your angle c, and that n over a is always going to be equal to the the sine of that angle c. All right, so let's do an example. We're going to do a couple of examples here. And I'm just pasting this at the top of this new page for reference. So what I want to do is I want to start with, I just want to rewrite four times the square root of 3 times the sine of 2x minus 4 cosine 2x as a single sinusoidal function. So what we have is this. I have effectively the left-hand side of this operation. So I know that, so what I'm going to do is I'm going to match this 4 square root 3 sine 2x. I'm going to write this as plus negative 4 times the cosine of 2x. And I'm matching that with my m sine bx plus n cosine bx. So this only works when your two waves have the same period. Okay? All right, so what I know here now is that m equals 4 times the square root of 3, n equals -4, and b equals 2. Okay, from the m and the n, I can get a squared, because a squared equals m squared times n squared, so that's 4 square root 3 plus -4 squared, which is going to be 16, so 48 plus 16 is something my head's not doing today. 48 plus 16 is 64. Now that's a squared, so from that I know that a is 8. Okay, how do I find c? Well, I know that m over a equals cosine of c, which means that the cosine of my angle c is equal to 4 square root 3 over 8, which is square root 3 over 2. Now, you may immediately think, oh, well, heck, that means c equals, what? Need my unit circle. Pi over 6. But we need to be a little careful, because pi over 6 is the first quadrant angle that has got a cosine of root 3 over 2. There's a fourth quadrant angle that has a cosine of root 3 over 2, and that is 11 pi over 6. How do I know which one is right? Well, that comes from my n, because I know that n over a is equal to the sine of my angle c, which means that my sine needs to be the negative for root 4 over 8, which means -1/2. So therefore I want the third quadrant angle, or excuse me, the fourth quadrant angle. Which means that I've got all my pieces, because I've got an A and a B and a C. And that's all I need to combine everything back together, because I'm building this. So what I'm going to do is I'm going to realize that 4 square root 3 times the sine of 2x minus 4 times the cosine of 2x is the exact same wave as 8 times the sine of 2x plus 11 pi over 6. And this would be my answer. And you may be thinking to yourself, no way, Jose, because both of those original angles, sine waves, have an amplitude less than 8. How do they combine together to make a larger amplitude wave? Well, let's look at this. Okay, if I'm not lying to you, then I should be able to graph the left-hand side of this. So 4 square root 3 times the sine, times the sine of 2x minus 4 times the cosine of 2x. And I'm telling you, am I telling you right? Yeah. So let's look at this wave. What's the amplitude of this wave? Well, the amplitude of this wave is 8. So according to what I did a minute ago, what should be its period? Well, its period should be 4. 2 pi over, no. So let's remember how to do this. My period is my natural period of 2 pi divided by my internal multiplier, which is 2. So my period should be pi. So let's give myself some multiple of pi steps. And because of the shift, it gets a little dicey, but let's look here. That's pi over 3, and that's 4 pi over 3. So yes, my period is indeed pi. And we could do a little bit of work and figure out relatively easily that I have a horizontal shift to the right of 11 pi over 6. And so yes, indeed, this is the same graph. And if you really don't believe me, we'll just put the right-hand side on here. And there we are, same thing. All right, that is all there is, almost, in this section. And we'll talk about the last little bit in yet one more video.